Nods of approval?
You can see your screen. It's all right.
Fantastic. Okay. Federico has already covered a lot of ground, but I'd like to spend the last 5-10 minutes just covering some things which we feel is also important to your overall managed estate. It's not just what you've got and where you've got it, but what is coming in and out. I'd like to just discuss a little bit of the data lifecycle within your MariaDB environment, particularly using Columnstore. And I think what's important, what we'll be touching on today, is all of this is readily available. It's there now. It's probably just an extra package or a plugin away for you from your existing package manager, whether you're using Community or Enterprise, MariaDB. I'm not going to be touching on anything that's completely foreign to the ecosystem. Everything is ready to go. Last month, we'll talk about two things really here, like how to kind of scale your workloads and keep your workloads scalable. I'm not going to talk about scalable analytics. I actually did in the webinar last month. So you should go ahead and watch that. Because if you're already using time series metrics, you've got this kind of like large batch scale data. Just throw it at Columnstore. Terabytes have it. Just go. Don't listen to me. Leave now. Go do it. You don't need any of this. I'm talking about how to use Columnstore and data warehouse to complement your OLTP workload, your online transaction processing workload, what you're doing in replication, synchronous, semi-synchronous, Galera, anything like that. Transactions come in and out. And what does this environment look like to you? So it's probably InnoDB behind the scene, and you've already tuned your individual servers or your small cluster estate to kind of handle this on like a per node basis. This is just an example. Perhaps you've got about 2,000 connections. That's what you're trying to get aim at with this kind of hardware. And your application backend developers are expecting milli-microsecond return and latency on queries. Nice and fast, data comes in and out, and you want to maintain that kind of performance on this kind of hardware, be it a virtual machine, hardware, anything, for about 3 to 5 years, perhaps to maximize returns. And perhaps this is what your estate kind of looks like, what your kind of workload looks like. Clients into a proxy, some kind of scaling solution for perhaps reads, writes, and maybe an offsite backup as well. As time goes on, you've got more data and you need to access it. Someone has the genius idea of creating a data warehouse. Okay, pretty good. That's a good first step. You're using the tools, load data, selecting to out file, CP import, or something like this. You're loading into a data warehouse. You're separating the workload, and you're starting to separate concerns, which is pretty good. This data warehouse can now start getting larger, whilst your lean, mean OLTP machine can keep doing the main churn. And those kind of extra reporting workloads, analytical workloads can be handled elsewhere, perhaps by the back end or a client. They know that the data is elsewhere. The only problem with data warehouse and this kind of hardware is it's a bit big and it's a bit expensive. And as time goes on, you often find that other people and other systems also want to use that data warehouse. And that's when things start getting a little trickier. So maybe if you haven't already done so, you should have made your data warehouse MariaDB Columnstore. Plenty of people pushed OLAP and queuing dimension techniques onto relational databases like InnoDB. If you perhaps already done this in Columnstore, or you're about to do this in Columnstore, your world is about to get a lot more simple. Unlike the rest of the ecosystem, Columnstore has its own method for scaling, and it's not replication or two-phase commits over a protocol like Galera. It has its own method of storing extent maps. And this is kind of 2-diagram example, 3 nodes in each, 3 servers in each. And on the left-hand side, we're just sharing storage, perhaps that's NetApp, NFS, iSCSI, something or other, a DAS or NAS. And on the other instance, the right-hand side, that storage is actually then backed by S3 or an S3 compatible storage layer. So you kind of push that concern off to the cloud, or at least an S3 compatible storage solution. So again, this will make your life so much easier, and your data estate can just grow and grow and grow, and you don't really have to worry about it as long as you've got the storage. And it's a wonderful solution, but it is separate to scaling MariaDB in the more traditional senses. So it does require a little bit of extra reading, or some expert consultants come and set it up for you. I'm going to keep saying things like Columnstore is very fast. It is very fast. And these are some metrics from last month's webinar, where I thought it'd be fun to try the 1 billion row challenge, which kind of became popular around January this year. And there's records and things kind of being set on that. But I kind of started with the baseline generation, and it took about 5 minutes loading that billion, and it generates 1 billion rows of data, a location and a measurement in temperature. And this billion rows took about 1:20 just to load into InnoDB. Loading it into Columnstore took 14 minutes. That's a considerable ramp up performance. And if you have a cluster, it will distribute this data among the extent maps, among the storage, so that all the cluster can access the data. Very nice. One more from the same challenge. To actually run the calculation, it offers you a baseline on how to calculate this average. And I got 3 minutes 22 just in the baseline Java, and then 52 seconds in Columnstore once it was loaded. And then nearly a quarter of an hour with just a regular InnoDB table. And I think it's important to note here, this is a different workload that is much more suitable to Columnstore for things like metrics and reporting, large-scale analytics, and in this case, between the Java InnoDB and the Columnstore query, we're running groups and sums, so aggregate queries, which it just rips apart. Off it goes. The workload kind of will start to seem very simple or familiar to. Oh, I've made a mistake there. That's not a select into out file on the last one. That's actually load data in file, that's supposed to be. So you're probably quite familiar with perhaps selecting into an out file, having that file, loading it into Columnstore. So just as I did in that previous slide, the load will be very, very quick depending on your data size. You'll probably be doing upload up archive or elsewhere to S3, and that'll probably be your option for reloading data should you need to. An important difference with any data warehouse or business intelligence solution is it shouldn't be your only source of truth for the data. It's just an option to start scaling your data estate. Sorry, that bottom one should be load data into out file. Load data from out file. It's not your only option kind of for spreading the load among your servers and things. If we think back to that original diagram where we had lots of kind of OLTP solutions kind of layered over each other and overlapping, you can start doing what I would call separation of concerns. And if there's one database system and server which has an inventory, for example, of goods in, and the sales team would like to see that inside another database, you can always use the Connect engine to read from that table from another database. This is particularly good in the case of things like access control layers. These two systems maintain their own access control layers. They have their own separate users and groups connecting to them, but a DBA or admin can allow access between these two servers, making the data between them a bit more transparent without actually having to move any data. And that's a big important. What's largely important about this idea is we haven't actually had to move any data. Sales is going to have its backup, inventory is going to have its backups and restore routines, and neither shall the twain meet, other than the occasional select query. The S3 engine has been an absolute savior for a lot of people. Again, this is separate to Columnstore. The Columnstore has an S3 compatibility layer to it for just storing data. The S3 engine is superb for handling things like archiving data. So again, perhaps we need to keep our OLTP servers lean and mean, move that data elsewhere, but we can still query it if we want to. But we do understand that we're adding a lot of network latency, and the whole round trip as the query comes in, it has to read to the start of the table. You'll probably be joining onto an archive table. That query has to finish, come back, return the rows, push it up to the client. So depending on the data size, that could take quite a while. And in this example, I'm kind of creating a goods in archive, which both these servers can see because there's one table in S3. And I just kind of created a table like the goods in archive. The goods in, created an archive, start transaction, select from one to another, perhaps where it was last year's data, deleted from the current one. When I did the alter table to engine equals S3, I was able to choose a custom algorithm, compression algorithm. And it's worth noting, this is a read-only operation. This is a great thing to do when you have to actually just push data away. And, it's elsewhere, perhaps you've done a backup, that's offsite. This archive has now been moved to S3. It's still accessible, but it's not updatable. So you're going to have to prepare to have that kind of process where you read it back, update it, push it back again. So it's good for older data that doesn't need updating anymore. Perhaps depending where you are in the world, you'll understand what your legal concerns are, like SOX compliance or GDPR, what you can have and where it can be. So we kind of seen like a couple of rushed examples there of how what it looked like before, what it looks like now. So we understand these are MariaDB solutions, and perhaps a lot of them are looking at Columnstore in the background, and we can start scaling these things independently. And they've all got their own kind of options for backup and moving data around, but it doesn't really make anything more transparent or as easy to see for the rest of the estate. As we'll come back to Federico's example of focus on these kind of components in the stack, which is the proxy. And I've actually added one more example here, which is the back end, because your developers or the product owners will know what is an acceptable query, or perhaps in their ORM, they'll know how to generate a query which can go to different servers. If people are familiar with like the Java drivers, you can have specify your replicas in a connection. So you already know that you can push off different rule sets like read and writes into different directions. Perhaps your writes will always go to the primary, your reads will go to a replica somewhere, but that's not always the kind of flexibility that you need. And that's where things like MaxScale, ProxySQL will allow you to then to write rules to be very specific about this query goes here. And in this case, I've just kind of been a bit aggressive, and I said anything with like an aggregate query in here. So select something sum, or select something average is going to the column store. And like I said, it's a bit aggressive, but you can absolutely make sure they go there. You could be a lot more specific in the rules there to make sure perhaps you're joining on different tables or different date or value ranges to make sure they go there. Or again, kind of put that into your back end, or both. So there's a lot of options there for managing the estate to kind of start keeping this spaghetti mess from becoming too difficult or awkward to start owning. And so people say to you, where is this record, or how can I find a record from a particular year and join it and compare it to like a newer trend that we're getting now? As many of you have probably found out over the years, or your other teams have said over the years, no, we don't have everything in one database, or it won't fit in one database anymore. It's affecting the SLA. It's affecting the time of backups, time of restores. We can't guarantee a fast enough solution without making compromises. Well, we're suggesting don't make compromises, just to expand the estate a little bit, maintain MariaDB compatibility, and just push things off to where you need to, and absolutely stay in control of it. So there's a little bit brief. I didn't want to take up too much of your time there. Should we stop for questions, Stacey?
Yes, I think we have some questions. Some new questions on the questions tab. Can MariaDB dump data table by table and keep the data consistent to have multiple SQL files instead of a big file?
Yeah, I could partially answer that one. It's the tab option, and I believe it does support single transaction.
I think I have an answer for that question. Okay, you mentioned you want to get a file per table, if I understand correctly. So, and you want the data to be consistent. So, I think it will be doable since the next major version of MariaDB. But it is also doable currently with MyDumper. The only problem is MyDumper is mostly for MySQL. So if you use MariaDB specific features, it's possible that MyDumper won't work. But again, it should. Test it, please. Don't take my word on it, but I think it will work.
Anyway, let me read aloud another question by Sebastian. Probably Federica has something to add. Would it be okay to leave user statistics to run all the times? Will it impact resources usage on a big database, for example, 1.5 terabyte database?
It is generally okay to leave it on all the time. There is only one drawback. If you have really many users, it might take too much memory. That's why the same plugin in Percona server has an option to limit the memory it can use in these cases. But for MariaDB, it doesn't have this option. So basically, if you don't have a lot of memory and you have a lot of users, that's the case when it can bring some problems. But it's not common anyway.
So another question. What is the state of Docker image? Okay. I guess the one for Columnstore.
Yeah, I think Richard has the answer.
Yeah, if you're referring to the Docker Columnstore image, there is we did release kind of a version that kind of worked. I was working on migrating some of the bash scripts in the background, which kind of pull it all together to Supervisor D to run the write engine, DDL proc, DML proc, worker node, controller node, and another process to Supervisor D, but that has not gone to plan. I think perhaps a better approach would be trying CMAPI within inside each node instead, and keeping that as a front end for trying to run the processes and keep them running. That's been by far the biggest problem in that, and as Federico mentioned earlier, and I can say with definite experience about running large MariaDB installations in Kubernetes in the cloud, it does not work well. There are so many external processes that run. And they wouldn't be fit for sidecar containers either inside something like Kubernetes. So I think we'll still have another go at it. When we kind of talked about that we were doing this, we also mentioned that we've linked a couple of tickets, one to the MariaDB Enterprise team to get it updated, and one to the community team for the foundation team to perhaps get Columnstore better integrated into the MariaDB server process, so there's fewer external processes. And I think that's been the biggest problem. It just runs so many external processes, and containers are processes. So in progress is my answer for that.